The question in this video is, do capacitors have a certain sound? There is a lot of discussion on all kinds of forums on the internet, and I wanted to do this test. It's a very simple test. This is a one-stage transistor amplifier. With this resistor we can set the amplification, and I connected a capacitor between the output and the input, and that means that we make the transistor stage frequency dependent, and in this case all high frequencies are cut off. So I want to study now whether the high cutoff, the sound, differs with different types of capacitors. Here is the circuit. This is the one-stage audio amplifier, the square wave and triangle wave oscillator, the sine wave oscillator, and at first the CD player, and of course my oscilloscope. Connect now the speaker, and here are all kinds of capacitors. This is a foil capacitor. This is also a foil capacitor, but from another type. This is a blue ceramic multi-layer capacitor used in for instance, computer power supplies. This is a small capacitor, ceramic, 10 nanofarad, and this is also a certain foil capacitor. All capacitors are 10 nanofarad. So we study now the damping that all these capacitors give on this music. Let's hear whether we hear differences. This is the first one, this capacitor. I disconnect it now. And we go to the ceramic capacitor. This is the ceramic capacitor. Let me first show the oscilloscope views. This is the ceramic capacitor. This is the first small green capacitor. Now we go to the ceramic multi-layer capacitor. First wait on the next number. This is the multi-layer capacitor. This is the small ceramic capacitor, 10 nanofarad. This is the foil capacitor. This is without any capacitor. And this is another foil capacitor, but now for 1500 volts. So these were the differences, or not, that you could hear. Now I connect the amplifier to the sine wave oscillator. One moment, put down the camera. And you can hear the frequency already. This is a sine wave on approximately 5000 Hertz. Put it there. 5000 Hertz sine wave, and this capacitor is now active. Now I go with this frequency to the next capacitor, that's this one. The same frequency. Here we see the damping again. There's an enormous loss in volume, in level, from this at this frequency. and that's normal. We go to the blue multi-layer capacitor. Blue multi-layer. 10 nanofarad ceramic capacitor, the small yellow one, and finally a foil capacitor again. Now we go to a low frequency. Again, this capacitor is active now, and I'll go up now on this row. This is a low frequency foil capacitor, ceramic capacitor, multi-layer, blue multi-layer capacitor. There is no effect because these low value capacitors don't give any damping on this frequency. They give only damping on higher frequencies. Very small damping they give, you can see it here. Also the 10 nanofarad ceramic. The 1500 volts 10 nanofarad capacitor, foil capacitor, and the aluminium looking capacitor. Now we go to the triangle wave and the square wave. This is the square wave. Connected it here. I go back to an audible frequency and go back to this big one, this one. I don't care about the waveform. I'm only interested in the differences. This is the big 1500 volts foil capacitor from 10 nanofarad. This is the aluminium capacitor, aluminium looking, it's also a foil capacitor. This is the blue ceramic multi-layer capacitor. This is the 10 nanofarad ceramic capacitor, the very small one. And this is the green capacitor, it's here, this green one. So I don't take conclusions on this test. I don't think there is much difference. Of course, this is a very simple filter, and it only damps on a very on one frequency or a part of the frequency band. So it's not specific. It has not have a certain band pass. But you can do tests on capacitors and on their effects on certain frequencies with this schematic. And of course, with complex filters, with a band pass filter, perhaps it's possible to see more effects from different types of capacitors. But this is only a very simple test.